Okay, for this question, we have given the function f of x is equal to 3x squared minus 4x plus 1. And then we are going to find f prime of a, namely the derivative of f at some number a. And at the moment, we can only use the definition of f prime of a. And we have two of them. I will show you the first one. So I will write down, okay, f prime of a by definition. This is what I call the definition 1. This is defined as the limit when x is approaching to the number that we are looking at right here, which is a. And then we have f of x minus f of a over x minus a. That's what I call the definition 1 of derivative. And now we just need to do the work. We have to make sure we set out the limit equations correctly. Let me write it down again. X approaching to a for the limit. Here we are looking at f of x, which is this. So I just need to plug that in for that. 3x squared minus 4x plus 1. That's f of x. And then I'm going to subtract f of a. And to get f of a, I have to plug in a into all the x in the function. But then since I'm subtracting the whole thing, let me open the big parentheses right here first. And I will plug in a into all the x, so I will get 3a squared minus 4a, and we have plus 1, like that. And for the denominator, we still have x minus a. Next, this is what we are going to do. This is going to be still the limit when x is approaching to a. And let me just write down the denominator, x minus a. The key right here is that I'm going to group these two together, and let me just show you how are we going to do it, and I'll tell you why in a minute. So I will write down 3x squared minus 3a squared. Okay, I'll group them together. We have the negative 4x minus negative 4a. In another word, we have negative 4x minus minus becomes plus 4a, just like that. We have 1 minus plus 1. In another word, they pretty much cancel each other out. So if you take out the parentheses, and then what I did just rearranging it, and this is what we have at the moment. And if you plug in a into all the x, we are going to end up with 0 over 0, and we should somehow see something that we can cancel on the top and with the bottom. And to do that, now I will tell you why I want to rearrange them. Because I can factor this by grouping, because we have 4 terms. For this part, both of them have the 3, so I can factor out a 3. And I will get x squared minus a squared, like that. Both of this have a 4, but then you have to maintain the same sign, so I'm going to factor out a negative 4 instead. I factor out negative 4, and then I'll open the parentheses. This right here will be x, but originally I have a positive right here. I factor out negative, so it becomes minus a right here. And then notice that this part, x squared minus a squared, this is the difference of 2 squares, so once again we can factor this out. And I'm going to put down the 3 right here, and then we'll break this down as x minus a times x plus a. And now we're ready. I will write this down as the limit when x is approaching to a, same thing. And then the denominator also stays the same, x minus a. But then on the numerator, this right here is the first term. I'm looking at this as 3 times x minus a times x plus a. That's the first term. And notice that for the second term, we also have x minus a. So we can factor out the x minus a. I'm going to factor out this x minus a. Okay? And now if you look at the first part, we will have 3 times x plus a left. I factor this out. Let me open the bigger parentheses. For the first part, I just have this thing left, which is 3 times x plus a. 3 times x plus a. And then I will have minus 4 left here for the second part. And as you can see, x minus a, they cancel each other out.